Good afternoon, Year 4, and welcome to your second science video on states of matter, where we'll just go through a little bit more of the knowledge. So, we've talked about air, which is not a nothing. Air has weight and it's all around us. This picture shows someone hang gliding. A hang glider has no engine or propellers, so why does it stay in the air? So pause the video and have a think. Why with no propellers, does this hang glider stay in the air? What is happening? Well, do you remember I talked about resistance on the other video? So hang gliders use air resistance to keep them up in the air. The air pushes against the wings and prevents it from falling straight to the ground. So we talked about that force of gravity, didn't we? And there are forces acting. So gravity is pulling us down, and there are other forces acting against it, okay? So you have to imagine there's like a force, can't really see it, but it's acting. I'm trying to show you it's pushing up and pushing down. And then when one of them is bigger than the other, it makes it either go up or it makes it go down. So being able to change the position, have I missed a bit? The air pushes up, yeah. Being able to change the position of the wings keeps it up for even longer. If air was nothing, it would not keep the hang glider floating and it would fall straight to earth. Can you think of any other examples that prove that air is not nothing? Pause the video and write them down. So what are the differences between solids, liquids and gases? Now we spoke about that last week. Do you remember how a solid keeps its shape, a liquid moves, and a gas moves even more? So we're introducing gases this week. We only talked about solids and liquids last week. So what would happen to this solid, liquid and gas if they were poured into these open containers? So if you put a cheese in here, water in here, and the gas in here, can you imagine what would happen to them? Well, the cheese would stay the same. The water would flow easily from the bottle and take the shape of the new container. So a liquid takes the shape of the new container. But the gas would spread out and take any available space, and it would, even if there was no lid, go up and take all of this space, and it would go wherever it can. And that's because the particles, which I mentioned last week, are behaving differently. So in solids, they're closely packed, and that means they can't move much. In liquids, they're spread out more, which means they can easily change shape. And in a gas, they're even more spaced out, so they can move to any available space. You could try this if you've got your family to help you or some toys. You could put them together and show them moving and show being a solid. You could make being a solid, make being a liquid, and make being a gas. These syringes have been filled with sand, water, and air. And what do you think will happen when each one is squashed down? So do you think anything will happen to the sand, to the liquid, or to the air? Well, the sand stayed the same. The liquid, interestingly, stayed the same, although I would have thought it would have squeezed up here, but perhaps it couldn't. But the air, look what's happened. It's gone down. Because the particles in the solids and liquids are more tightly packed together, you cannot compress them very much. But gas is easier to compress because the particles are spread out so much. Can you match these sentences to the correct state? So I change shape to fit my container. Does that go to a solid, a liquid, or a gas? That's right, it goes to a liquid. I keep flowing until I have used up all the space. I change shape to fill any space. I cannot flow. I keep the same shape and I flow easily. So have a think, which ones do they go to? So a solid was, I cannot flow and I keep the same shape. A liquid was, I change shape to fit my container and I flow easily. And a gas was, I keep flowing till I have used all the space. I change shape to fill any space. Now there's some more activities on Teams, and I mentioned there's a science little experiment to do with if you've got a fizzy drink at home. So have fun with this, and we'll see you next week for Science Week. Hooray! So at school, we're going to be doing some science on Monday. Bye-bye.